everyone, welcome to Physics by Aaryan. I'm very happy to welcome you all in this next class of free foundation physics course. So in previous classes, we discussed basic graphical analysis, basic mathematical tools, which you might need for your competitive exams. Now we are going to start basic mechanics, all the basic concepts of mechanics that you might need in your physics exams. So in this context, the first topic which I am going to cover is kinematics. Kinematics means kinetics. Kinetics means motion. So whenever an object is in motion and we want to study it, we have some set of equations and some rules which we obey. So I have divided kinematics in two parts. Number one part is motion in one dimension. So whenever the motion is in one dimension, that we will study first. Okay. So in this context, the first concept which I want to teach you is average speed and average velocity. Now this concept may seem very simple, but can be very tricky at many times. So average speed is nothing but equals to total distance upon total time. So whatever is the total distance you have covered. What is distance? So distance is a total length that you have traveled. So let's say you start from a point and moves in a circle. So this entire length or entire circumference which you have traveled is known as distance, divided by total time. So total time means whatever time you have taken to complete the motion. Now this was average speed. Now this is a scalar quantity. There is no direction. It is simply a scalar quantity. And average velocity is total displacement upon total time. So what is displacement? So displacement means how much your object has been displaced. So let's say you start from here and completes a circle and come back here. It means your particle has not been displaced at all. It is at the same position from where it started. So the displacement of the particle is zero. But let's say if you start from here and goes here, then what is the displacement? This is your displacement, and this is equals to 2 times the radius. Or let's say your particle starts from here and reach here. So what is the displacement? Your displacement is like this straight line. How much your particle has been displaced from your original point, that is known as displacement, divided by total time, which means how much time your object has taken to complete the motion. Okay, let's move to next part. I want to complete this concept using one example. This is why one of the favorite example and covers each and every concept of average speed and average velocity very nicely. So the question in front of you is, an object is moving in a circle with the uniform speed of v. So there is one object which is rotating in a circle with a uniform speed of v. And you are asked that what is an average speed and what is an average velocity when object moves from A to B. So object moves from A to B, you have to tell me what is average speed and what is average velocity. So let's calculate. So number one thing is, it has, if you see A and B has an angle 120 degree. It means how much rotation it has done? 120 degree. So what is the total displacement then? Sorry, what is the total distance then? So you know, if I complete the entire circle, the displacement distance we covered will be 2 pi r, which is circumference. If I cover 360 degree rotation, my distance covered will be 2 pi r. But since I have covered 120, which means 1/3, my distance will be 2 pi r by 3. So this is what I have written here. My distance is 2 pi r by 3. Now what about time? So if I cover a complete circle, it means I have covered a total of 2 pi r, and the time which I have used is speed v. So what is the formula for time? So the time is given as distance upon speed. So if I complete an entire circle, the distance which I will be covering is 2 pi r, and speed is given to me is v. But since I have covered 1/3, so I will take 1/3 time. So my time will be 1/3 of 2 pi r by v. So if you divide both of this, the answer you will get is v. So the average speed of this motion is v only. So an object is moving with an uniform speed of v, and the average of this will come out also to be v. This was about speed. But what about average velocity? So now let's see what is an average velocity in this problem. So we have moved from A to B. Fine. So let me redraw this diagram here. So we go from A to B. What is our total displacement? The formula for average velocity is total displacement upon total time. So what is our total displacement? So we have gone from A to B. So whenever you have to find a displacement, you have to make a straight line from your initial point to final point. So if I make a straight line from A to B, you get this line AB. And you need to find this AB. Okay. And what will be AB is, AB will be final position minus initial position. So your final position is OB and your initial position is OA. Now we will use the basic vectors knowledge to find the AB, the length of this AB. So the vector addition law says if your C is equals to A minus B, C vector equals to A vector minus B vector, and you want to find the magnitude of C vector, then the magnitude of C vector is A square plus B square minus 2AB cos theta, where theta is an angle between A and B. So similarly, here what I want to find is, I want to find AB. So what will be my formula? So my AB will be under root of OA square plus under root of OB plus OB square minus 2 OAOB cos theta. And cos theta is an angle between my initial line and the final line. Or you can say initial position vector and the final position. So if I put, so you can clearly see OA is radius, or maybe in this diagram you can just clearly visualize OA is radius, also OB is radius. So OA square plus OB square means R square plus R square minus OA R and OBR. So minus 2R square, and angle between them is 120. So cos 120. Cos 120 is minus 1 by 2. So if you put a value, you will get under root 3R. Okay, you will get under root 3R. So this is your total displacement. Time will still remain same. As I mentioned, total time is total distance by total speed. But since you have covered 1/3 distance, the time will be 2 pi r by 3v. So your total displacement is root 3v through root 3r, and your total time is 2 pi r by 3v. Solving this will get you the average velocity. So this is how you find an average velocity and average distance. So always remember these concepts, that average distance is an actual length which you have covered. But however, the total displacement is the straight line from initial position to the final position. And then you use the laws of trigonometry or vectors to find the displacement. If you do not recap this parallelogram law, I have given the basic requisite notes in my website. Please go and read them. Those notes covers this vectors topic very nicely. Okay. Okay. Next question. So the next question is, the question in front of you is, an object moves with velocity v and then hits the wall. So this object was moving with velocity v and then hits the wall and bounce back with velocity v by 2. So an object was going in a straight line, it hits the wall and bounce back with velocity v by 2. What is an average velocity? So you see the total displacement is 0. Why? It started from this point and finally it came back to that same point. It means it has not displaced at all. So the total displacement is 0. It means average velocity is also 0. But the average speed will not be 0. Why? Because even though displacement is 0, the object still has covered some distance. The object has moved. It means object has covered some distance. Might be displacement is 0, but distance will not be 0. So what is the total distance then? So it goes in this direction by amount d, and then also come back in this direction by amount d. So the total distance covered is 2d. What is the time? So always remember the time is distance upon speed. So the time to go from here A to B is d by v, and the time to come back is d by v by 2. So the total time will be 3d by v. So what will be an average speed? Average speed will be total distance upon total speed, that will be 2 by 3 times v. So I hope that you will remember, you have understood this question. If not, you can ask me any doubt at any time in Telegram channel or maybe in the comments of this video, wherever you want. Okay. So this was the concept 1 where I wanted to know, where I want you to know that average speed and average velocity. Now let's come to concept 2. So concept 2 is equations of motion. So in our initial classes of physics, might be you will get nostalgic after this. We have studied 3 equations of motion. Equations of motion are always applicable when acceleration is uniform. Whenever the acceleration is constant, so let's say motion under gravity. In motion under gravity, the acceleration is constant and it is minus 9.8. But in a situation where acceleration is not constant, in that scenario, we cannot use equations of motion. So whenever your acceleration is constant, we have 3 equations. One is v equals to u plus at. Another is s equals to ut plus half at square. And the third is v square minus u square equals to 2as. What is v here? V is the final velocity. Let's say your object starts moving and ultimately it reaches to some velocity. So whatever is the final velocity is known as v. Whatever is your initial velocity is known as u. So your object starts doing some motion. So let's say initially it has some velocity. So that will be your u. A is acceleration and t is time. And s is the total distance or total displacement. Okay, so s will be the displacement of an object. Fine. So this is your equation of motion. Now I want you to explain. I want some question. I want to explain one question in front of you so that you get a very good practice of this. So the question in front of you is a ball is thrown up. So we have one ball. We throw this ball up with an initial speed of 20 meters per second. So when I throw a ball up, I give it some velocity. That velocity is 20 meters per second. So as you predict, the ball will go up. So as the ball is going up, the gravity is pulling it down. So since gravity is pulling it down, its speed will reduce. So its speed will keep on reducing until it becomes 0 at A. So I want to repeat this, that a ball is thrown up with 20 meters per second. It is going up. When it is going up, gravity is pulling it down. Since gravity is pulling it down, the speed will keep on decreasing. Ultimately, what will happen is at the top point, the velocity will become 0. And after this, gravity will completely pull it down and it will start coming down. So this is how our motion will look like. So initially, we will go from 0 to A and then from A to B. Okay. So first question in front of us is, what is this maximum height? So what is this height OA up to which the ball will go up? So how we can solve this? So we have to use equations of motion. Why? Because acceleration is uniform. That is why we can use equation of motion. So we will apply equation of motion between 0 to A. So this is your point 0 and this is your point A. Let's apply equation of motion between 0 to A. So my initial speed is 20, u is 20. My acceleration, let's take as 10. So my acceleration is minus 10. Why minus 10? Because gravity always acts downward. So since something is acting downward, it will be negative. So my acceleration will be negative. S I want to find. So I want to really find what is the total distance it has covered. So going from 0 to A, what is the total distance or what is the total displacement? That is my purpose. That is what I want to find. And what about my final velocity? It will be 0. As I mentioned at the top, the velocity will be 0. So ball will slowly decrease its speed and ultimately it will become zero. So velocity is zero at the top. Okay, so let's just apply a simple equation. B square minus U square equals to 2as. B 0, U 400. If you put all these values, you will get S equals to 20 meters. It means the ball will go up by 20 meters. So this is how you solved the equation number 1, or you can say question number 1, in which we were asked to find the total displacement of the ball above the ground, or above the building, or you can say what is the maximum height of the ball. Now, second part is what is the time it will take to reach the maximum height. We understood that it will go 20 meters above the height or above the building, but what is the total time that it will take? Again, we will use the same analysis. U is 20, V is 0, final velocity is 0, initial is 20, and acceleration is minus 10. So V equals to U plus 80. And if you put the values, you will get T equals to 2 seconds. So the total time it will take to go from 0 to A is 2 seconds. So we got our second answer as well. Okay. Now let's come to third. Third is find the velocity with which it hits the ground. Now the question is interesting. So after A, what will happen is ball will start coming down and it will keep on increasing its speed because ball is coming down. Gravity is pulling it down. So if gravity is pulling it down, the downward speed will keep on increasing. So starting from 0, the speed will keep on increasing and it will hit the ground with some speed V. So it will hit the ground with some speed V. And you want to find this V. Okay, understood. Now what I will do is, now I will use the equation of motion between A and B. So I will use equation of motion between A and B. So since velocity at A is 0, it means my initial speed is 0. And what is my total displacement? So you will cover first 20 meter and then 50 meter. 50 meter is the height of the building and 20 meter is the ball above the roof of the building. So the total you have to cover is 70 meter. So your total displacement is minus 70. Why? Because you will cover it in the downward direction. Since you will cover it in the downward direction, you have to say your displacement is minus 70. Your acceleration is minus 10. So you will use a formula of V square minus U square equals to 2as. So if you put a value in V square minus U square equals to 2as, the final velocity that you will get is under root 1400. So the ball will hit the ground with a speed of under root 1400 meter per second, which is somewhere less 30 to 40, in between 30 to 40 meter per second. So I hope that you understood this. Then the question is, what is the time to reach bottom? So how much time it will take to go from up to down? So you know, V we have already calculated. It is under root 1400. U is 0. Acceleration is minus 10 and time is unknown. So V equals to U plus 80 we will use. If you solve this, you will get roughly 3.8 seconds. So in order to go from very top of air to the bottom of the ground, you will take 3.8 seconds. So this is what the formula is about. Okay, so we use the equation of motion 4 times to find the questions in different parts. First time we use the equation of motion between 0 to A. So 0 to A we found. Then we use the equation of motion between A and B to find the other two questions. So this is how the mechanics works. Equations of motion will remain same, but whatever you want to find, you can apply the equation of motion accordingly. So you have to practice these kind of questions a lot so that you can actually get a basic idea. So I have given the notes. There are some problems in those notes. You can briefly solve those problems. You don't have to go in much depth for these topics, I would say. The reason being, you should have a basic intuition for all these things. You should not start doing many problems related to this. The reason being, because there are so many problems out there and they are not very directly important to our exam preparations like JAM, JEST, TIFR. But you should have a very basic understanding that, okay, this is how the things works in mechanics. That is more important. Okay, having a physical intuition about mechanics. Okay, so now let's move to concept number 3. Concept number 3, which I want to cover, is graphs. Motion graphs. Very important topic. So many times a graph is given to us and we want to extract the information from that graph. So there are many kind of graphs which we can make. Number one type of graph is position time graph. So you are plotting displacement versus time. What is your displacement and what is your time? So displacement is on y-axis and time is on x-axis. So the number one graph, which is an object is at rest. So let's say this is an origin. An object is sitting here, which is at distance 10 meters away from origin. So the position of object is 10 meters at all times. At all the times, the position will remain 10 meters. Since body is not moving, the position is not changing. So you can see this graph, parallel lines. So you can see your x is 10 meters, x is 10 meters at all the time. It is not changing. So whenever something is not changing with time, you get a parallel line. Okay, so your x remains constant, parallel line or constant line. So your x remains, your position remains constant with time. This is how you plot a graph. Now, if I would have said, okay, your position is at -10, so my graph would be like this. X equals to -10. Okay. So if your position would have said it is sitting at origin, so then my graph would have been like this. On the origin, I will make a line. Okay. Now, what if you are moving with the uniform velocity? Let's say you are moving with the uniform velocity. How will your position versus time graph will be? So we know the equation x equals to ut plus half at square. In this equation, we assume that your motion starts from origin. It means, what does it mean? When time is 0, your position is 0. But let's say when time is 0, your position is x0. Then this equation becomes this. So if at time t equals to 0, your position is not 0, but it is x0, then your formula becomes ut plus half at square plus x0. So with this said, let's see. So x equals to x0 plus ut plus half at square. And since the velocity is uniform, acceleration is 0. So your equation becomes x equals to x0 plus ut, or ut plus x0. Now, you can clearly see x depends upon t, means t power 1. So whenever something depends upon power 1, it means you will get a straight line. This is very much clear. So let's just compare this. So you have an equation x equals to ut plus x0. Now let's compare this with our straight line equation. I have taught you straight line equation in graphical analysis. So straight line equation is y equals to mx plus c. You can clearly see that your position is y, means on y-axis you are plotting your position. On x-axis you are plotting your time. So this u will be your slope. Your velocity will be your slope. So slope gives you the velocity. So if you plot position versus time graph, then the information that you will get from the slope is velocity. Now, second, y-intercept. Y-intercept will give you x0, which means initial position. So when the time was 0, at what position your particle was. So that will give you by the information of x0. Now let's try to see the question. So the graph is given to you. Graph has been given to you and you have been asked that, tell me about this motion. What kind of motion is happening? So you can clearly see the c is -10. Means your initial position is -10. So your particle is sitting at -10. And the slope, what is the slope? Using the rules I taught you in the graphical analysis class, you can easily find that slope is 2 meters per second. So the slope is 2 meters per second. It means your object starts from -10 and moving with the speed of 2 meters per second. This is what your graph is. So your object starting from -10, and since the slope is 2, it means your speed is 2. So you start from -10 and you moves with the speed of 2 meters per second. And you will keep on moving. This is your graph. Okay. This is how you can take out an information from a graph. Next part. Next part is also very interesting. So the train starts from origin. So train started from origin and moves with 20 meters per second and stops at a station after 2 hours. So you start from, so your train is starting from origin. It moves with 20 meters per second and then it stops after 2 hours. Station arrives and it stops. So what will be the graph? So you see, you start from origin. You move with 20 meters, means your slope will be 20. So your slope will be 20. So you move with 20 meters per second and then you stop. Stop means velocity 0. Velocity 0 means slope 0. So then you stop. So this slope will be 0 here. Then let's read the next point. It stops at a station after 2 hours for 1 hour. So it means it remains stopped for 1 hour. So after 2 hours, it reached the station, it stopped, and for 1 hour, it remains stopped there. And then it starts moving with the uniform speed of 10 meters per second. So you can clearly see for 1 hour, means for 1 hour, it remains stopped there. And then it starts moving with the velocity of 10 meters. It means the slope will be 10. So you can clearly see the slope of third line is less than the slope of second line. This is how you plot a graph. First, you make a slope 20, then you stop it, and then you make a slope of 10. And you will get your final graph. Okay. Always remember, whenever the velocity is uniform, you will get a straight line in xt graph. In position time graph, you will get a straight. Fine. With this said, let's do the third example. Third case is your acceleration is not 0. You have some acceleration. So what will be the graph in that situation? You can clearly see x equals to ut plus half at square. Now you can clearly see x depends upon t square. Whenever x depends upon t power 2, you get a parabola. So you got a parabola. So I have made 2 parabolas. One on this side and one on the other side. And I want you to explain that how we can tell that acceleration is positive or negative. Is it positive or negative? In first graph, acceleration is positive or negative. And in second graph, is acceleration positive or negative? So we studied that slope gives you velocity. So what I will do is, I will make slopes at different points. What is slope? Tangent to the graph. I gave you the 2 definitions in the graphical analysis class, that slope is given by the tangent to the graph. So let's make a tangent. So you can see tangent here is like this. Tangent here is like this. Tangent here is like this. So you can clearly see the slope of your tangent is increasing. You can see, right? The slope of your tangent is increasing. It means your velocity is increasing. So if your velocity is increasing, it means your acceleration is positive. Now let's come to second graph. Again, make a tangent. So you see your x tangents, the slope of your tangent is decreasing. This line is more inclined. This line is more flat. It means your slope is decreasing. If the slope is decreasing, it means velocity is decreasing. It means acceleration is negative. So this is how we can find from the graph that if the acceleration is positive or acceleration is negative. Okay, so this you can see that acceleration is positive here, and this you can see acceleration is negative. Okay, so this was all about position time graph. Now let's come to velocity time graph. We can also draw velocity versus time graph. So number one situation is uniform velocity, which means acceleration is 0. So your velocity remain constant. So your velocity is constant. It means you will get a parallel line. So with time, your velocity is not changing. So what line you will get? You will get a parallel line. So this is how you plot a uniform velocity graph when VT graph is there. Second situation is uniform acceleration. So in the first case, your acceleration is positive. So your initial velocity was there. and your acceleration was positive, so you will draw a straight line. So why I'm making straight line? Because you know v equals to u plus at. So v is directly proportional to t. It means you are getting a straight line. What is your y-intercept? Your y-intercept is initial velocity. And what is your slope? Your slope is acceleration. Okay, since the slope is positive, acceleration is positive, your slope will also be positive. Now, what if your acceleration is negative? So if your acceleration is negative, your slope will also be negative. So you will start from initial speed of u, but since your slope is negative, you will come down. Okay, so the rule to remember here is the slope of velocity time graph is acceleration. And the area under velocity time graph is displacement. So let's say I ask you that I give you some velocity time graph. For example, in this case, I am giving you some velocity time graph and I ask you that once it goes from time 0 to time 6 seconds, what is the total displacement of the body? So what I will do is I will find the total area under the graph. So I will find the area under object shape A, area under shape B, and area under shape C. So shape A is rectangular, so it will be base into height. Height into base will give you 4 into 2, 8. The area of shape B is base is 2 and the height is -2. So your base is -2 into 2 minus 4. And the area of shape C is simply 2 into 2, 4. So if you add all these three, 4 and 4 will cancel out and your total displacement will be 8. So you will totally, so let's say you start your motion from 0, then you move 8 meter above, then 4 meter back, and then again 4 meter above. So ultimately how much you have traveled, these two will cancel out. The ultimate displacement will be 8. So you are again finally at this position. So you first reach till 8, then you come back 4, and then you again go in front 4. So you're finally here. So this distance is 8. So your total displacement is 8. But what about distance? Distance is an actual path covered. So in distance, whatever is your negative numbers, make them positive and then add. So if I make them positive and then add, so 8 plus 4 is 12 and 12 plus 4 is 16. And this you can actually see from diagram also. You will first go here 8, then 4 here. So you have traveled 4 more. It means you have traveled 12. And then 4 more. It means 12 plus 4, 16. Your displacement was 8, but the actual distance you have traveled is 16. Okay. I hope that you understood this concept. The law which I want to give you is, if you have a displacement, let's say I give you displacement and you want to find the velocity, what you do is you do a differentiation. And if you want to find and if you have a velocity and you want to find an acceleration, you again do a differentiation. Or you can say double differentiation of displacement. So let's say you have x and you want to find v, you do differentiation. And let's say you have v and you want to find acceleration, what you will do is again differentiation, or you can say double differentiation of position. Similarly, if I want to come in back in reverse direction, I have an acceleration, but I want to find velocity, so I will do integration. And let's say I have a velocity and I want to find displacement, I will again do a integration. So if you want to go from displacement to acceleration, you have to do differentiation. Or if you want to come from acceleration to displacement, you will do a integration. This is a very simple rule. In graphs, the slope is defined by differentiation. I also already discussed about this thing in graphical analysis lecture, that the differentiation tells you the slope. However, the area under graph tells you the integration. So whatever is an area under graph, that will give you an integration. For example, I want you to have this information. Let's say you have a PV graph, pressure versus volume graph. You have some graph. Area under this graph will be P into dV, which means integration. I just mentioned that area under graph is integration, which means P dV integration. And this you know is known as work done. So always remember, whatever graph you're making, the area under that graph will be integration. And integration gives you many different things. Now, for example, another thing like force versus displacement. Now, area will be F dx. Now, again, you know, F dx gives you work done. So area can give you many kind of information, depends upon what kind of graph you are studying. Okay. Okay. Next concept which I want to teach you is relative velocity. We covered average velocity, average speed. Then we covered our equations of motion. Then we covered graphs, and now I want to cover relative velocity. Okay. So you have two buses or two cars, let's say car A and car B. Car A is moving with velocity of VA and car B is moving with velocity of VB. I ask you that what is the relative velocity of B with respect to A? That what will be the speed that A will think that B have? That what will be the speed of B according to A? This symbol is given by VBA. So the relative velocity of B with respect to A is given by VBA. VBA is nothing but VB minus VA. Whatever is your VB minus whatever is your VA. That will tell you what is the speed of B according to A. Similarly, you can reverse this. If someone asks what is the speed of A with respect to B, then you say it is VA minus V. So let's see with an example. So A is moving with 10 meters per second and B is also moving with 10 meters per second. What will be VBA? Means the speed of B with respect to A, it is 20 minus 10, 10. So if both the cars are moving in the same direction, the relative speed between them will be less. Why? Because see, the difference in speed between them is less. So they will think that, okay, motion is not that fast. Motion is not that fast. Okay. Similarly, VAB is just the reverse. So VAB will be minus 10. So if someone asks what is the velocity of A with respect to B, you will simply say it is minus 10. Okay. Now, next part. In next question, what is happening is object A is moving in the forward direction. However, object B is moving with the backward direction. So velocity of A is 10, but the velocity of B is minus 20. So what will be the relative speed between them? So you can clearly see now instead of VB, you will say VB is not 20, but it is minus 20. Why? Because it is coming in the opposite direction. So minus 20 minus 10 will give you minus 30. So now you see if the two bodies are coming in an opposite direction, the velocities add up. So their relative velocity will be much more. You can imagine this. Let's say there is one car moving in a straight line and some car comes from back and hit this. The damage will be less. But let's say two cars are coming head to head and they collide. The damage will be more. It means in this situation, relative speed was more. In this situation, relative speed was less. Okay. So this is what I want to make a point about the relative velocity. I'm giving you everything in a very quick manner. The reason being because this is not our main motive. This is just to make your basics okay. That whenever we talk about these things in our actual syllabus, you actually feel that, okay, you know these things. You have revised these things. So out of the entire class 11th or class 12th mechanics, I have summarized few things that you might need in your physics syllabus of these competitive exams. Okay, the last question of this lecture which I want to discuss is, so what happened is monkey is running on the top of a train A. So there is a train on the top, monkey is running opposite to the velocity of train A. So this train A is moving. So this is train A and the monkey is running on this top in the opposite way. So the train A is traveling with the velocity of 20 meters. So the velocity of the train is 20 meters. And the velocity of the monkey with respect to train A is 10. So the monkey, according to train A, the speed of the monkey is 10. But then you are asked that what is the speed of monkey with respect to ground? If some person is sitting on the ground, what will be the relative speed of the monkey with respect to ground? So what is an information that is given to you? Let me solve this question live in front of you. So number one information is given that velocity of train is 20 meter per second. Second information that is given is the velocity of monkey with respect to train A is 10. Now this will not be 10, it will be minus 10. Why? Because the monkey is going in the opposite direction as train. So the velocity of monkey with respect to train A is minus 10. What is VMA? It is nothing but VM minus VA. So your equation is minus 10, VM minus VA. Okay. Now, VM minus VA. So VM you want to find out and VA is given to you as 20. It means your velocity of monkey with respect to ground is 10. So with respect to ground, the velocity of your monkey is 10 meter per second. Okay. So this is all about motion in one dimension. The next topic which I want to cover is motion in two dimensions. This is relatively small topic. You only need one topic in this. So you can start doing motion in 1D and later in the evening, you will also get a second lecture of kinematics. I don't want to give you all the lectures at one time and make you confused. So you can cover the lecture 1 till the evening time, and in the evening you will receive the second lecture which is on motion in 2D. So today we will complete both the lectures. So see you all. The second lecture will be available roughly at 8 or 9 p.m. That is relatively a small lecture, so you can complete it very fast. So I have already uploaded notes. Also the quiz of kinematics and all the quizzes has been uploaded on the website. So just go to our website. If you are new and you are watching these kind of videos for first time, then you can see a foundation physics video. I have clearly explained that how you can join the foundation physics course, which is completely free for all. Okay, so see you all in the next class. Goodbye, everyone. Best of luck.